Hello, and welcome to the DesignBase Advanced PowerFlow Program tutorial. In this lesson, we will learn how to run a basic PowerFlow analysis on a network of your choice. Let's begin by opening the file of interest. While doing this, make sure that the file contains a viable network free of modeling errors. Before we begin, notice that this file has two operating scenarios. In scenario 1, the network is powered from the utility, and in scenario 2, it is powered from the generator. These scenarios will enable us to analyze the behavior of the system when powered from either one of these sources. For our initial analysis, we'll select scenario 1 and use the utility as the power source. Now, let's invoke the Advanced PowerFlow program by selecting the Advanced PowerFlow option from the Analysis menu. Alternatively, you may also select the Advanced PowerFlow icon from the Tools icon palette. Now let's take a minute to familiarize ourselves with the different tools available in the interface. The first setting is the Analysis pick list. Here's where you can choose the different types of PowerFlow analyses to use in your study. In our case, let's select the Advanced PowerFlow option. The first icon gives you access to the Area Power Control options. This is a special type of PowerFlow study which will be addressed in other tutorials in this series. For now, we'll simply skip this section. The next command invokes the PowerFlow options. Here, we define critical parameters that will control the calculation process. Let's start by selecting the Newton-Raphson method as the algorithm of choice. We'll leave the Auto Text Report option deselected. This basically means that the results of the analysis will be displayed right onto the single line diagram instead of using a written report. Written reports will be addressed later on in this tutorial. We will ignore harmonic components by deselecting this option. Also, please note that there are no harmonic loads to worry about in this example. Next, make sure that limits and controls are set to the off position and that all automatic voltage control options are deselected as shown here. Automatic voltage control will be addressed in other tutorials in this series. In the Convergence Settings section, make sure that an adequate number of iterations have been allowed for the analysis to converge. Please note that electrical networks that are not viable from an engineering standpoint will not converge regardless of the number of iterations allowed. In such cases, troubleshooting of your design will be required. This topic will be addressed in other more advanced tutorials in this series. For now, leave this value at 1,000 iterations. In the tolerance field, make sure that the tolerance error is several orders of magnitude smaller than the smallest load represented in your model. We will set our error to 1 times 10 to the minus 6 MVA, which is more than adequate to accommodate the smallest load in our network, which is equal to 100 kVA. In the Advanced Options section, leave both settings deselected for this example. They are not needed for our study, but will be explained in further tutorials in this series. Select OK to return to the main screen. The next icon is the Analyze button, and it is used to run the actual PowerFlow calculations. Let's proceed to complete our setup before executing this step. Next is the PowerFlow Back Annotation control icon. Here we decide what and how it gets displayed under the single line diagram. Let's turn on the annotation by toggling this button to the on position. Next, select the Auto Refresh option to automatically update the back annotated results. In the Color and Font section, we can select the type of font to use, and the decimal precision with which to annotate the results can be defined by moving this slider to the desired value. In the AC PowerFlow tab and section, select the specific parameters and results that you wish to display under the single line diagram. In our example, we will choose bus and branch name, bus voltage, current flow, voltage drop, and branch loading. Next, let's choose to display flow arrows by selecting this box and define arrow type and size as shown here. In the Unit section, select your preferred units for voltage, current, capacity, and branch losses. In the bus, current, and transformer violation fields, define values for violation limits and percentage, as well as the colors that will correspond to each of the limits. Press OK to complete your selections and return to the main screen. The last icon is the Scenario Voltage Profile field. We will return to this command later on during this tutorial. Now that we have completed our basic analysis setup, let's proceed to run the analysis by selecting the Analyze button. Once the analysis is completed and convergence has been successfully achieved, the results are shown under the single line diagram. Notice that as per our preferences, the buses are displaying the calculated voltage values and voltage drops, and the branches are showing the flow current and corresponding percent loading. Also notice that buses and branches with violations are colored using the guidelines defined in the back annotation menu. As a matter of interest, notice that the reactive power compensation provided by the capacitor PFC1 is shown as an injection of current into bus SWG2. If you would prefer to show the reactive power flow in kVAR units, simply select the appropriate output option in the back annotation interface. Now let's take a look at the Report Manager command. Here you can create many types of reports depending on your specific requirements. Options range from fully detailed reports all the way down to condensed ones for voltage and current violations. The Report Manager also includes the ability to export to Excel spreadsheets as well as a full-fledged professional report writer. Let's review a couple of these options. For instance, selecting the output results to digital meters allows you to very quickly navigate the results of the study using different types of gauges and outputs that provide great visual impact. It also allows you to filter results based on voltage and current violations. This interface is very handy if you're doing a presentation to an audience and don't want to scroll up and down through a lengthy text report. Selecting the Report Format 1, you can generate a complete report that includes results for all buses and branches based on preferences defined in this options screen. These preferences are type of output units, report sections to include, and violation criteria for voltage and current. Once your preferences have been defined, select OK to generate the document. The final report includes sections for system information, summary of generation and demand, and all bus voltage and branch current reports selected in the previous option screen. Close the report and select Exit to return to the main menu. The last icon in the series is the Scenario Voltage Profile command. This function allows you to run simultaneous load flow analyses for all or a selected number of scenarios present in your network's topology. Let's proceed and launch the application. Notice that all scenarios that have been defined in the network are shown in the Available Scenarios column. In order to select individual scenarios to study, simply click on the scenario of interest and press Add. This process can be repeated for every scenario that you wish to have analyzed. Note that as you select them, they appear listed in the Selected Scenarios column. If you wish to eliminate a scenario from the selected column, simply click on the scenario and press the Remove or Remove All command. In our example, we will include all available scenarios, so let's select Add All. In the Unit Settings section, define the units and the decimal precision with which you wish to display the voltage results. In the Voltage Limits section, enter the upper and lower acceptable values for this parameter. Calculated results outside of these limits are considered to be a violation and will be reported as such. Please note that these values are entered as percentage of the nominal voltage that corresponds to each bus in the network. Select Run to proceed with the calculation. The final report shows the calculated voltages at each bus that correspond to the operating scenario selected for the analysis. In our case, all of them. Close the report and select Close to return to the main menu. Thank you for watching, and stay tuned for more video tutorials in this series.